So this is chapter 20, the last one of the book, apart from the appendices, building a multi-threaded web server. I'll try and do a quite whistle-stop tour of what it talks you through and some of the key bits of functionality and some of the subtleties, so that we can get onto at the end some of the issues Alex and I have discussed and some of the slight subtleties of this chapter. So we're building a single-threaded web server to start with. Then we're trying to make it multi-threaded and then sorting down the shutdown and cleanup. Out of the box, Rust provides the ability to deal with HTTP and TCP protocols, sending HTTP over TCP. I will say from the start, I'm not a web person, so I won't go into detail about those, but the chapter kind of talks through the simple parts of it anyway. So it provides a TCP listener, and we can listen out for TCP data streams at an address. So here we are using the standard library net TCP listener. We're binding to that address, and it returns a result in case the bind fails. For example, if you need admin privileges to listen on that port, or if someone else is already listening to it. So if you accidentally already have it running in another instance, then you'll hit that error. We can then look out for incoming streams, unwrap them as they come, and then do something with them. We use the prelude include to give access to traits to read and write from the stream. And so this bit of code here now is we're adding in a handle connection behavior. We need to take a mutable stream, because a stream is kind of like, if you've ever, similar to like an iterator, I guess, where you have to kind of walk the data. It's holding an internal state. So that's why as you read it, you're actually changing it. We create a buffer and then use that buffer to read out the data. And then once we've got it, we can then use the from UTF-8 lossy to filter out any bad UTF-8 characters and convert it to a string that we can then print. Depending on what browser you're using, you'll get different results. So here we're using Google Chrome, so you can see it writes that out for us. But if I do the same thing from Edge, you can see you get Edge. And the general structure of this is you've got a method like get, and then the request URI, which in my case was just the root level, and then an HTTP version. You then have a long list of headers. So this is this long list here, which has things like the host, the connection, and if it was a post request, then you might have a body as well. But for a get request, the body is going to be empty. You can then construct a response. The format of that is similar, so that kind of in reverse. So you've got the HTTP version, then you've got a status code, which you'll recognize, and the reason for that, which in this case is OK, and then some kind of carriage return line feed at the end. You then have the headers, similar to what we saw earlier, and then a message body. So a response with no body and no header and just 200 response would look like this. So that's us returning that response. We could then change it to return a whole HTML page by saving our HTML into a file, reading that file out to a string, and then returning that as the contents. The contents is going to be in the body of the response, but we also need to specify a header, which is going to show the content length. And that's what this is doing here. So you can see we're saying the content length is the length of the string we read out, and then the contents is the HTML contents. Cool. And then we can check the incoming request and change our response accordingly if we want. So at the minute we're responding to the same way, no matter what path has come in after this port. But if we want to make it so we error with 404, if whatever's after here doesn't match, then we can do that. So we're saying this is the string we want to look for. It's a byte string, and then we take the buffer and we check whether or not it starts with that byte string, and if it does, we return our HTML page, and if not, we could return a 404 error page instead. We can also then just combine these so that we don't have too much duplicate code by saying, okay, if the buffer starts with this, then we're going to get out this status line and this file path. If not, we're going to say 404 with a different file, with our 404 error page, and then read it out exactly the same. You're just returning a response. It's this bit that's giving us the error code, so that's taken care of, and it all just works, which we'll see in a minute. And that was single threaded. It's very easy. Just to be clear, in case this isn't what you would actually do if you were writing a web server yourself. This is just showing you the raw out-of-the-box stuff that Rust gives you. So if you put this in a project, you wouldn't need to include any extra libraries in your cargo.toml, or you can just straight away set up listening on a port. To make it multi-threaded, which we might want to do if we want to be able to respond to additional requests as they're coming in, even if we're still processing a previous request, then we're going to want to create some threads. We don't want a thread per request because that's going to be a huge number of threads. You're not going to have that many hardware threads, and it's just going to end up being a bottleneck. So instead, you want to create a thread pool that you queue up tasks on so that you can limit that to a sensible number of threads. There isn't a thread pool in the standard library. There are lots of libraries that provide them, but in this bit of the chapter, it shows you how to create a basic one for yourself. We're going to do that by creating a struct, which is going to internally manage a queue of jobs to be executed on different threads. So here we've got the same code as before, but what we're going to want after we've created our struct is to be able to say, okay, give me a new thread pool with 4 threads on it. And then we're going to want to execute the handle connection logic, which is the thing that might take a while, on the thread pool instead of doing it on our main thread. The thread pool itself is managed with a multiple, oh, I've already forgot what it's called. What is it called? My brain's drawn a total blank. The MSPC, what does that stand for? Multiple source producer, no, multiple producer, did I get the letters the wrong way around? Is that why? Yeah, multiple producer, single consumer. That's why it doesn't make sense. I've written it the wrong way around. And so our system, our overall struct is going to consist of some jobs, which are the things that we're going to send to our pool. They're going to be a closure that we're going to execute on the thread pool. We're going to have the thread pool itself, which is going to send jobs along some kind of channel to worker threads that it's going to own. And it's that bit of the process that we're going to implement now. So the job needs to be passed to the thread in the calling code. So this is the code from earlier. This is where it's passing some kind of closure to be executed, or in this case, it's a function pointer. Actually, no, we are passing it, so it's a closure. The thread pool is going to contain a vector of workers. There's going to be 1 thread per worker when the worker's created. And then we're going to have a sender that's going to send the jobs to the worker threads. It's not sending it to a specific thread. It's just sending it down that multiple producer, single consumer path. It's kind of slightly confusing. There is, we're actually only having 1 producer, which is our thread pool itself. That's the thing that's producing it's passing along these jobs basically down the channel. And yes, we have a single consumer, but we're going to do a little trick so that it can kind of behave as if there's multiple consumers so that we can consume it on the different threads. We'll come to that in a second. So the worker thread is going to contain an ID just for housekeeping, and then a join handle so that we can join the threads at the end. So this is how it's working with the multiple producer, single consumer. We've got an atomically reference counted type, which is a smart pointer that's atomically reference counted so that it can be shared. And then we've mutex locked our receiver, which means basically that each of our threads can have a shared reference to the same single consumer, but only if it manages to get the lock on the mutex can it receive any information from that channel. So the logic for creating the thread looks something like this. So you spawned a thread and you've got a loop that's going on, and this loop is going to keep trying to basically get a lock on this receiver. The first one to manage to get the lock will then be trying to receive any information from the channel. Then once it's received the information from the channel, it will then, this lock is only held for a short amount of time. As a result of us doing it in this let statement, it's only temporarily held, so we don't need to worry about it not getting dropped. It will be dropped. And then it can execute the job once we've got it. But something else while we're executing that job might pick up the lock and wait for the next thing to be on the receiver. And that way you're going to be kind of moving down through the threads where if one's busy, something else will pick it up. If that makes sense. I think it's a slightly funny pattern, but it seems to work, kind of. This is the bit where, in actual talk at the end, where we found things weren't working quite how we expected or quite how the book describes. So we'll be interested if anyone else did have a chance to go through the chapter, if they found the same issues. The idea is that when we're shutting down, we want the threads to stop looping, waiting for jobs at some point. So maybe we only want to listen to 10 requests and then we want to shut down the application. So when we do the clear up, we want the threads to be joined and we want them to have completed any executing jobs. What's slightly weird about our case is that we've got that loop statement, that infinite loop that is never going to break. So if we try and join on that thread, it's still never going to complete. We're never going to get that cleanup. So we need to sort that out. So for joining threads, we could have initially, we need to, what do we want to do the cleanup? We probably want it to be the thread pool. So we might implement a naive drop statement within our current implementation, but we'll find that it fails to compile. And the reason is that we can't take the workers out mutably. We can't move them out of the worker thread without leaving the worker thread in a bad state, without leaving the worker in a bad state. So we can't get the thread to join it. To get around that, which is going to make it optional, and that way we can take the underlying item from it, we can move out of it and leave it with none, rather than leaving it in an undefined state. So now we can move the thread out of our workers, and currently executing jobs will finish, but the loops are still going to kind of keep going because we don't have any terminate in there. The way we're going to do that is by adding an additional message. So instead of just passing the job, which is our closure, directly to the worker thread, we're going to wrap it in a message. So it's either going to be passing a job or it's going to be passing a terminate message. When we receive that terminate message, we're going to break out of the loop, and that way when someone tries to join on this thread, they're going to be able to see that thread complete because we're no longer in this loop. Which should, in theory, then mean that if we want to shut down our thread without shutting down our applications, we can do that. It'll go through the normal drop and everything will be fine. This was not a huge amount of code, as Alex will show you when we actually look at it in Visual Studio Code, but it was still like 139 lines for something relatively simple. If you use a library like Rocket, you can drop that down to just 25 lines. So this also takes care of a lot of the subtleties that are very easy to get wrong in the code we just wrote. With Rocket, it's much harder to get wrong and it's much more reliable. It's a library that someone spent a lot of time writing, working with those underlying like primitive standard library types. So in Rocket, you would just do something like you'd include file system thread and some kind of sleep. One thing I didn't mention is in the earlier examples, when you work through the book, it gets you to have one of your responses sleep, which is kind of just to simulate doing some work where we didn't actually have any work to do. So we have our overall Rocket launcher. This is like Rocket's version of main. This launch outer attribute, which is a procedural macro, will generate a main under the hood for you, which will have some async behavior and will do the listening. You then say, okay, well, what are the catches and what are the routes that I want it to follow? So the catches is my 404 error, so I can catch 404. And then if nothing's found, then I can just send my 404 HTML page again. I could also have looked at what the request was if you wanted to add in some extra info. I have my sleep, which just sleeps and then returns my hello HTML page. And then I have my root level one, which just again returns the HTML page. And that does exactly the same code, exactly the same result, with some additional kind of error handling and things that Rocket takes care of under the hood, but you get the exact same result. Very, very easy.
So when you, sorry to interrupt, but when you specify which functions are your routes, so when you do the mount, when you make a web request to this as your URL, will that be /hello and /sleep? Does it pull the directory?
It's not from get hello, so this is just the root level. I've called it hello.
Oh, sorry.
But this is the bit that has the end of the path. The sleep one is sleep though.
Sorry, that's my eyesight failing me. I missed that.
Oh, it's this font as well. It's not very easy to read. Yeah, and you can add in arbitrarily complicated ones. You can add in then things like query parameters that you can then parse out, which it's got some really nice behavior where you can then have a struct that defines your query parameters. And then you can just say, okay, the query parameters are going to be these. this is the type it's going to be, and then it will parse it for you. You can use things like, you can combine it with a bunch of other libraries like sturdy JSON and stuff to then return JSON objects instead of HTML pages, and it's quite an easy to work with library, I think. And the way it makes it so easy is just by using procedural macros, which just allow you to get rid of a ton of boilerplate code by generating it for you. And that's it. That's chapter 20. So just using standard library, we can listen for requests and send responses. It's not a huge amount of code. That's still only 125 lines, but it could be less if you use a library. And that's the end of chapter 20. But so here's the gotchas. So when Alex went through this, he found something. I'm going to pass over to him because I also couldn't figure out what it seems like it's a mistake in the book, but how you resolve it is not totally clear. And I feel like there's some investigation to be done.
Yeah, thank you, Ciara. It's not going to be very satisfying because I found a bug, and Ciara and I spent quite a lot of time looking at it yesterday. I spent a bit of time a few weeks ago when I actually went through the book trying to work out what's wrong. I didn't really get anywhere, so I'm kind of hoping I can harness the power of the group to to solve this. So if I just take over screen share. Oh, sorry, Ciara, you cancel. Thank you. And I got too many windows open. Bear with me. Can you see that? Okay.
Yep, can see that.
Cool. Thanks. So crucially, when you reach the end of the book, it gives you all the source code for this example. So that I've just very quickly pulled that from there. So this is definitely all their code, with the exception of line 13 in the main.rs. So as you're working through the book, right before the very end, when we're handling graceful cleanup, they mentioned, because we're, sorry, you can tell I haven't rehearsed this very well. Because we want to limit the number of, or we want the ability to do a clean close when we have a limited number of requests, they demonstrate limited number of requests using take from incoming. So that basically just means, hey, accept the first two requests, then end this for loop. And once we leave main, that's when we'll trigger the thread pools drop, and that will start shutting down all the workers. So what I've noticed is that when I run this, when I hit the limit, it'll shut down some of the worker threads, but I then have to make another web request to get the thread pool to actually continue with the drop. And it's a bit weird. I've tried, I'll clear this and I'll run the example, show you. So you can't see it, but on my other screen, I'm running an instance of Google Chrome, and I've just got a web page that will make a request just like it describes in the book. Google Chrome, when you reload a page, seems to make multiple requests. So that was just one. And you can see we got a job for worker 0 and worker 1. We must have ended the main loop because we've printed shutting down and we've gone into the thread pools drop. And the screen share banner is right in my way. Apologies. There's too many buttons. So we can see we've entered the drop for the thread pool because we've sent the terminate message to all workers, and we shutting down all workers. So we have sent all the terminate messages that we want to send. So we've sent one for each worker, but because of the way the workers are set up, they can't accept more than one terminate message. So there's at least one in the multiple producer single consumer channel for each one of them to pick something up. And we sent a message to shut down worker 0 and worker 1. And presumably what's happening is that it's waiting on this thread join. But it's a little bit unclear why it's doing that, because it should have finished its job, and then it should have been able to pick up its terminate message. I'm just trying to remember where exactly in this thing of source code they have that. Yeah, so this is the closure that the thread is running. It's an infinite loop, which we only break out of when we receive a terminate message. So presumably, if this was still processing, it would finish its job, and then it would go around into another instance of the loop and wait to receive something from this channel. Receive is a blocking call, I believe, so it just waits on this thread until it receives something. And that is about as far as I got, because it must be waiting somewhere. But if that's the case, then I don't see why. If I'm just going to click this again, so if I click this, sorry, I'm going to send another request, and my browser appears to be very slow. I don't know why that's slow locally.
That's what happened to me when I set it to 5. I think it might be some kind of race condition where you can end up where you stop receiving requests as well. So I think there's something deadlocking, and it's in an earlier chapter where Rust doesn't protect you from deadlocks, but it's not nice to think that it's in an example in the book if that's what's happening. I'd be very interested to know if anyone also ran into this and has any ideas of how we could modify the existing code to fix it. We did have the idea that maybe if we add in another channel that sends a message from the worker threads back to the thread pool that can basically say when the loop's been broken, so you don't try and join any threads until you've completed all of the loops. So you've broken out of all of the loops, then maybe that would fix it. I haven't actually tried it yet, so we could try that now. If anyone has any ideas as well, that seems like a hack rather than a fix.
Yeah, it is a bit worrying, given that one of the sort of main motivations for Rust was Mozilla trying to make their multi-processing safer.
And I think it is safer if you do. I think this is a toy example of how you would do the cleanup, and I think it's just conceptually wrong, but I can't quite reason about why. It seems like it should work.
I mean, I guess one way to try investigating it would be to separate the multi-threading of what you're doing from the web server aspect. So just turn it into a standalone application that is receiving messages by looking at files or some simpler form of communication. Picking up events and see if you get the same problem on that. So at least you could divorce the problem from the TCP.
Yeah, we should be able to really straightforwardly take it out of the web server thing, because all we need to do is have a loop that sends 4 closures to to this, and then break that out into a helper method. Because that's all that's doing when it receives an incoming message is sending them. So we could just
each time you run it, Alex, is it always just it terminates 2 of them but not the others? Is it reproducible in exactly what it's doing? I'm just wondering if it's like those 2 are the ones that actually did some work and the others didn't do any work, so for some reason they then don't keep looping.
So that would be my suspicion. I've tried this on and off over the last couple of weeks. I can't remember if it was consistent, but one easy way to find out will be to just run it again. So I will just run it again quickly.
Well, the other thing is we bumped it up to taking more yesterday.
That's very strange.
Only 1 shutdown.
Well, I didn't even go to the. I suppose I have the web page open, so perhaps it's just constantly pinging.
I think if you up the take to take like 5 requests,
Yeah,
so all of them will have done some work. Then we can see them doing work.
If you're offering 5 requests and there's 4 threads, then the load isn't going to be balanced, right? So if it's not balanced, I suppose that the logic isn't there.
I mean, it's pretty balanced. You can't really balance 5 over 4 more than going 1, 2, 3, 4, and then the first thread should get another one.
But what happens to the second thread?
So the first thread should get the first job, the second thread should get the second, third gets the third, fourth gets the fourth, and then the first thread should get the 5th request, which should be what we'll see now. And you need to probably refresh the page again, Alex, to get some more requests going in.
That's interesting. So I pressed it twice there, 3 times. 4.
Yeah. So that should be.
And we got 1, 2, 3 told to terminate, not 0.
Yeah, so this is consistent with what I saw yesterday as well. So all of them have done work. Worker 0, 1, 2, and 3 have all done work, but 1, 2, and 3 will have all finished, whereas 0 will still be executing the loop when terminate gets called. So it seems like somehow that's stopping terminate getting through, even though what should happen is when you join on that thread, it should still loop again and pick up the terminate. So why isn't it? Why isn't it picking up the terminate?
Can we go back to that closure, please, Alex?
Yes, this closure or the one that handles the. You know what? I've realised what you're asking. This one.
Yes, sorry. Yeah, this one.
Yeah. Yeah. So it just infinite loops. The only point it could actually block is here when it's actually waiting for something in the receiver. But because of the way it's structured, there should be. Once you terminate, there should always be something in the receiver for it to grab.
And the drop loop, are you printing out as you're sending each drop instruction or drop instruction to each of the drop message?
So in the drop for thread pool, we print once before we send to everybody, and then we print for each individual worker before we attempt to join that thread.
And we did check all 4 workers are there. Nothing crazy has happened where the workers somehow gone. That wouldn't make any sense. But
yeah, no.
Yeah, it all still seems fine.
It's almost like the drop loop itself is being killed partway through.
But it's the first thread that we're not seeing get joined.
Which kind of implies that it's not getting some thread when you call take here.
If you like replace that if let on line 65 with a match and then handle that error and just print out something.
It's not crashing. There is no error. So there won't be an error on the unwrap because otherwise it would have crashed.
Yeah.
This is all happening on the main thread.
Or you could do an else, or you can just do an else here, because if it is failing on line 65 or that condition is not true, then at least we can kind of clear that out.
Oh, I see what you mean now. You're right. That definitely could be it. That's probably exactly the issue.
Sorry, could you say that again? So if that fails, you wanted me to print something else, and
yeah,
I just as I was typing that, I missed the end of your sentence, Chris.
No, well, I have no idea what's going to happen, but this is one way to kind of capture. Yeah.
I think you're right, because take's not a blocking call. Take succeeds or fails, and if it fails, we don't do anything. We just loop onto the next worker, which would make sense why it was the first thread then that failed again. Although actually, why would it fail to take?
So 1, 2, 3, 4. We didn't get any failed messages,
No, okay.
but if I send another request,
Just remember, take is only for is that just because it's optional? It's nothing to do with the thread. And there's no reason why it should fail to move from the.
And why
from an
does it
optional.
send additional messages when Alex sends another request?
It's almost as if the implementation of receive is that it will, if you try and grab something, it won't try and grab it again until the receive thread, the receive channel like announces that it's got something to get. So it could be, because it's not try receive, it's receive. So you grab it, there's nothing there to grab. Okay, well, I'll wait until there's something in the channel to get. But then, of course, as soon as it gets added, you would, yeah.
But I mean, you could be like, if it's done by like some kind of waking pattern or something, but it only wakes things that are currently trying to receive or something like that, then maybe things can get like left in the channel, but things that are waiting to receive it don't know it's there.
So perhaps then we could try using try receive, and if that succeeds, we'll do as normal, and if it fails, we just keep going in the loop.
Yeah,
might be worth a go. I mean, I think there's a try receive.
yeah, there is.
This is when you find out that it might.
But we don't want
bones thing I haven't got.
Well, we don't want to unwrap the try receive if it failed. So we don't want to panic if it's empty. We want to check the result. So we want to put it in a match statement or something, and then unwrap the result if it succeeds.
Receive consumes the data, right?
Yeah.
Is it an optional it's returning, or is it an error, or potentially an error? Result.
Do you not have the Rust analyzer installed on your environment?
No, this is what I'm just saying. This is just a very quick installation I put it together.
Check yield doc.
Yeah. It returns a result. So. I guess we want to do nothing, and if it's
the other option could be that maybe that unwrap on receive is failing. Did we try that yesterday? I can't remember.
Your exclamation mark's on the wrong side, mate.
Thank you. You can tell I'm rusty.
Very good. You're here all week, Alex.
We might not want to put a print statement in there because it's probably gonna loop a lot. Is it? Yeah, it's not a blocking call, so that loop's just gonna thrash. There's no sleep in there.
Do you recommend using a panic rather than a print line?
Well, no, because if we panic, then we're not going to get anything. We could put in a sleep statement.
We could.
And then that way it'll only print every now and then. Might need to mute Christoph.
Oh.
Yeah, I mean it's still real expected to print all the time. It's duration.
Yeah,
too.
Duration, mate.
Should find examples.
Is it not just? No, it's
so the parameter that you pass in is because you got to manually do it, haven't you?
Yeah. Is it not just stood thread sleep?
Well, you've already got a stood thread line above. You need
Yeah, but I haven't scoped it, have I? So I'll.
Right.
I've lost my line now.
So
There we go.
And then in between the parentheses, mate, you're gonna have to pass in duration : :
Oh yes.
as or 2 secs or 2 milliseconds or I think
I
it's 2.
need to include duration, don't I?
yeah, include your stood time duration and then from 6. Maybe get it to every 5 seconds just because otherwise it's probably gonna print way too much.
Cool. Right.
We're not actually unwrapping. So we're now, when it's okay, we need to set the message in. So you might want to change it to.
Oh, I see. Yes. I'll have to.
Actually, the structure. Yeah, but you have to move all the code below line 95 down.
Yes, that's right.
Because otherwise we'd need to add something else to the enum to indicate do nothing and continue to loop, which seems cool.
Right. Please forgive my coding sins tonight as I
Just trying to find the
butcher
answer.
my way through a solution live on
Sacrifice will
stream.
need to be made, Alex.
Okay. Okay. Oh, error receiving on empty channel. So it,
Does try receive print anyway?
I think I am printing the error, aren't I? Where did I put it? Yes, I print error E. So error receiving on an empty channel.
So we've got a question in the chat. What happens if you use receive instead of try receive blocking versus more non-blocking? So originally we were using just receive, but the problem we're running into is that our cleanup code is somehow getting stuck and not cleaning up all the threads, and we're trying to figure out where that block is happening. So we're trying to see, is it in the receive that it's happening? Is it in the mutex locking that it's happening? Is it in thread join? There's somewhere that it's going wrong. And if you copy the code from chapter 20 and just run it in VS Code, you'll probably see the same thing as we're seeing if you have like take 2. So as a way of like limiting the number of requests so that you shut down after a certain number of requests, there's a bit in the example where it says, okay, we'll take 2 incoming requests and then finish. Yeah.
So this, so it's interesting to note that before I started sending any requests, we were getting this error receiving on empty channel, which means we were going through this and getting nothing back from the receiver and printing here okay. I've now got to the point where we told it to shut down, and we're not getting any more of these error messages anymore. So more convinced something's deadlocked, but maybe not here.
Could be the mutex on receiver lock.
Possibly. Could well be.
The thread join seemed more right, but then I can't think why thread join would fail unless this was already blocked in another thread.
We don't need to solve this today. I should point out, whatever happens, it may be that we'll end up raising an issue against the book in its GitHub repository, and we can we can credit the group. We've tackled this as a group, and we've struggled as a group. And now it's doing the thing where I've asked to send another request, and it's all timed out now. It's all locked up.
Could try switching the lock to a try lock.
Could do.
So do the same as we've done for try receive.
So try lock again will return a result, I suppose. But then we'll have to match it, won't we?
Yeah, it's not going to be pretty code. But...
No.
So how many pipelines of information is the data coming down on? When you create a new worker, does each worker have its own channel that it works on?
Same channel, and then the way it handles the fact that it's a single consumer is that it has it mutex locked in a reference counted smart pointer. So it's atomically reference counted and it's in a mutex lock. So in order to then access the receiver to see if there's anything in the channel, you have to unlock the mutex and then check, basically. Our fearless concurrency is feeling a lot less fearless today.
Well, we're here to learn.
Yeah, exactly. We now started having a look at Rocket's implementation of this. It's just so different because they don't do anything to do with like a thread pool like this, isn't it? I think we'd be better off looking at like a naive thread pool. I like Richard's idea of taking out the messaging entirely and seeing if we still get it without that. Let me try that.
So just making sure I'm not doing anything silly. So we start our loop, we try to lock. If it's okay, we try receive because that should have unwrapped. Then we match that. And if it's okay, we'll either perform the job if it's job, or we'll terminate if we've got the terminate message. If we tried to receive and we failed, it'll give us that empty channel receive error.
So,
and if the top match statement fails on trying to grab the lock, it'll print and tell us that it couldn't get the lock. And then it's going to sleep and try again. Sorry, Ciara.
Could you scroll up the error messages a second just to double check this?
Yes.
Yeah. Okay. Cool.
I've made a mistake somewhere apparently. Oh yes.
And someone's just said I want to make sure I have a different error message depending on whether they've failed on receive or lock. It should give a different one anyway, I think. Because we're printing the error that the try lock gives us versus the try receive, which should already have an error.
Yeah, but I think it's a fair point.
Yeah,
can't do any harm, can it? Thank you for the suggestion, whoever that was. Okay, so running. Try lock failed because the operation would block. I guess that's because somebody's already got it.
Mm-hmm.
And then I've made a request. I'll make another one. And another. So that's 3.
It's all going to work a 0.
4. Shutting down. Shutting. So if I make another one.
They all terminated.
Yeah.
Our sleeps might be interfering with it.
Quite possibly.
But yeah. That does suggest maybe the lock is involved, which makes sense. Because it wasn't fixed by doing the try receive.
We butchered the nice books code.
But we made it shut down correctly.
Well, no, because I still had to do an extra request to get it past the shutdown.
Yeah. Do you want to drop it down to 2 again?
Yeah.
Down from 5.
2, good idea.
Oh, I actually meant on the number of requests before it.
Oh, sorry.
Terminates, but fair is also good.
Sorry, which one or both or?
Actually, yeah, maybe no, you're right. Let's drop it down on here first and then see what we get. See if we still get everything going to worker 2.
Yeah. Bet you guys weren't expecting a pair programming presentation. Right. So we're getting all of our try locks failing and our empty channel receiving. That's good. So I've refreshed. That's once. Twice. 3 times. 4 times. So
we might want to put a sleep in the job for the channels to, sorry, for the threads to take, just so that the first one doesn't keep getting the lock. But yeah.
But that has got that. And there's no real difference there. We're just printing the try lock failed message more often. Yeah, I'll try reducing the number of requests we take to 2.
And put a sleep in handle connection
Yes, good idea.
if there isn't already.
Um,
Only if it's /sleep, actually. So you could just do /sleep in your URL request.
That's a good point. Yes, I will do that. How long does that wait? That waits 5 seconds again.
Mm-hmm. Should mean the tasks move forward onto the other threads.
Yeah. Okay. 1 sleep. Did that just say shutting down?
Yeah, we dropped it down to 2 though, and
Yes,
1
that's right.
refresh can be 2. Still only worker 0 got the job, right?
Yep. That kind of makes sense because it's the first request. Send a second thing over. And yeah.
So sorry, everyone, we don't have a solution to this, or I fully understand why it's happening. It does seem like it should work.
Yeah, I realize we're sort of getting to the end of the hour. I mean, we've got a few more minutes. If anyone else has any other ideas, we'll try and squeeze them in. But personally, I'm fresh out beyond raising an issue at this point. It's not the most satisfying way to end the Rust book, I realize, but
but it does show like, oh, look how much more there is to learn.
It's a very positive spin on it.
I would say I think it's a pretty spectacular achievement from you guys, having worked through. I know you didn't do every chapter, but you did the majority of the chapters and maybe 1 or 2 other sort of guest appearances. But getting through the entire book, it's taken quite a bit of effort and energy. So well done on all of that. I was also going to ask, is there somewhere sensible you could post your code or project, Alex, or your branch, so that other people can try pulling it down and giving it a go and figuring it out?
I can certainly upload something, but it is, if you go right to the end of the book, it's exactly the same as all the source code there, bar 1 line which needs to be changed. But I can certainly upload this later and put a link in the Discord.
Now you've issued a challenge.
Yeah, I say issued a challenge. It's just teach me, please.
It shows as well how annoying it is to debug problems with the bits of code you don't have, because some of the only things we really, I mean, I guess we have access to all the source code, but the mutex is something which I think is like handled at the OS level to a certain degree. So I don't think you can debug into all of that code. And then the receive channel, I'm not sure how that's managed, but those are the bits that I think are causing the issues. Is thread join. Those are like it makes debugging a real pain in the butt because there's no easy entry point to looking at what's happening there.
One thing I've not tried is running this on a Linux box. So, I've only observed this bug because I've only tried it on Windows. So that would be rather scary if it's an OS thing.
Don't say that. Oh,
oh, bloody Windows.
Stepped away for a minute. I don't know if you've tried it, but how well does Visual Studio's debugger cope with a multi-threaded application if you tried it?
So for this one, I think it's not too bad. When you pause in VS Code, it shows you the other threads and it pauses the other ones and shows you where your breakpoint is. I
should clarify, because this is a fresh install. I've pretty much got nothing, so I've got no debugging set up for Rust at the moment, I'm afraid. This is not my usual Rust development machine. Well, on that note, so I'll push this up somewhere, and I'll make it accessible. I'll put a link in the Discord later. In fact, seeing as we're here, I will just put another fresh link in the Discord. A fresh link for the Discord, just in case anyone's not been before. Bear with me.
So the reason
I'll pop a link now, Daniel. There you are.
The reason it's not in the meetup is quite sad, because we basically had someone hijack the permanent link address, so it took you to a spam page, and we can't generate a new permanent one. So they expire every week, is it, or every few days?
I think it's every 24 hours actually.
24 hours. So click that link fast, folks.
Yeah, we wanted to keep it open and accessible as possible, so anyone could sort of join. But unfortunately, that invites you up to anyone can join, and they are not always as interested in learning Rust as we are.
Cheers, guys, for going through that.
You're welcome, Chris.
Thank you. I really thought some of those things. I was like, maybe we'll find it. Maybe we'll find it, but not quite yet.
No joy. While we've got just a couple of minutes left, Ciara, do you want to talk about some of the other events we've got coming up? Because we don't just do the Rust Book Club, we do other stuff too.
Right. So we've got some events coming up. Richard, who's on the call, is gonna be doing a meetup next week, which I'm really looking forward to. So yeah, it's using Rust to read the little schema, which I'm very intrigued by. And then I'm going to be doing a talk about cargo expand, because when we went through the macros section of the book, we had some people asking about the use of cargo expand, and specifically procedural macros, because it's very hard in a session to go into that much detail about how you go about writing them. So we're going to try and do that. Again, I'm by no means an expert, but we'll kind of go through some of the tools available to us and how to do that. And then Alex is going to cover kind of a comparison of concepts and traits. So concepts in C++ are similar to traits. We're seeing quite a few rusty tools and rusty idioms kind of moving their way into C++, which is really nice. We've even got Cidic Spect coming in C++ 23, which is similar to result. But yeah, concepts is one of the ones, and other languages have them as well. But yeah, looking forward to that. Got other things coming. We're hopefully going to try and think of maybe another book to go through. We could go through the async one, open to ideas. And if anyone's got any talks they want to do on anything, then there'll be, we're open to any ideas, basically. Anything that you think is interesting, we'll probably think is interesting as well. Just saw someone in the chat said that they won't be able to join next week, but they'll watch it on YouTube. So yeah, that'll be great. And yeah, please come and do a talk as well.
Yeah, that's true. The floor is open to anyone. So if you just drop a message in the Discord just to say you're interested in giving a talk, by all means, we'll get in touch and we'll sort something out.
And that could be for anything, like a project you've been working on, or an idea you've got, or a problem you've been stuck on, or something you fancy having a go at explaining that other people have been stuck on.
Yeah, we've had a bit of variety in the past. So Richard's done a few. So a few months ago now, I think, Richard talked us through his C++ project, recreating the Enigma machine. A long time ago, I say a long time ago, I've lost, over the pandemic, I've lost all sense of timescales, but Ciara did an investigation into how fast square root works, which is the square root function of fame from, I think it's Quake, isn't it?
Yeah, Quake 3.
Quake 3, yeah. We've had some wild stuff over the years.
Quake 2, Quake 3, not sure, but yeah. And those should all be on YouTube. If you think we've missed one, let us know. Anywhere we haven't had issues with the recording, and we tried to put up even ones where we have had issues, so notice any fudgy bits, that's why. And yeah, I'd highly recommend doing a talk on something to people, because it's a nice motivator. It's something that you're interested in, but you're finding it hard to make the time to dig into it. Sometimes signing yourself up for something can be a great way to give yourself the nudge to get it done.
And as you've probably worked out from the code, the sort of code exploration we did today, expertise is not required.
Just enthusiasm.
There's the after party over at Discord.
If people want to go to the Discord for the after party, then they're more than welcome to. I'm afraid I need to shoot off, so I can't stick around today. But it's always free. Whoever's around, just make yourself known.
Yeah, I'll be able to join for maybe 5-10 minutes, then I'll head on. But if people want to try out the Discord, then I'll be there.
I can't help thinking that the collection of videos we've got, which must cover, we've got the videos for the whole book, for all the chapters, because I mean, it seems like that's the sort of resource that's worth pointing people at from a more general Rust site somewhere as something they'd be interested in.
Yeah, I can try and kind of share them. I think it's all, we're always kind of hesitant because we always intended them to be kind of discussion groups.
Yeah.
So it kind of would give people the opportunity to ask questions. So that I guess we don't want them to be just like the authoritative source.
No,
but I do
indeed.
think they're
clearly they're not designed to be a tutorial. You know, they are a more discussive, if you like, amateur understanding of the book. Still seem to have a lot of value for people who are trying to get going.
Yeah, definitely. We'll definitely point people at it in the future, especially I think as like a companion to the book. The book's great, but sometimes I think it's easy to get snowblind to it, and to kind of get lost in some of the subtleties of it. But then having someone else be like, oh, this is what I noticed, it makes you see it slightly differently, which is nice.
It's maybe more accessible, hearing other people who are learning it, explaining it as they understand it.
That's our hope. I think obviously apart from this one, I think they're all up on YouTube now, aren't they, Ciara?
Yeah, I think we skipped the first couple of chapters. We might have even done one of them in person when we started, I'm not sure. But the first couple were a bit more kind of getting people set up with Rust. So like helping people like install the tool chain and things, which we hope there's enough videos out online that people figure that out. But then the later chapters should all be up there, I think from chapter 4 onwards.
Just having a scan through the chat just for last things. So we just had some thanks come through. Thank you guys. Thanks for coming along and following through with us. For anyone who came partway through our chapters, again, as we've just been saying, it should all be on YouTube, and if it's not, it'll be up soon. And yeah, we're going to keep doing events and things, so please come along more often.
All right. See you all next week.
Thanks, everyone.
Thank you.
Bye-bye.